Hello everyone, I hope you guys are doing well. I am your friend Manish and today we are going to discuss the most important and sometimes considered to be the difficult topic, which is prototypal inheritance. Because it is a bigger topic, we will split it into multiple parts, and today we are going to discuss the very basics, which is what is prototypal inheritance, how we can achieve prototypal inheritance in JavaScript, and at the end of this video we will discuss the interview questions based on prototypal inheritance. So without any further delay, let's get started. So what is prototypal inheritance? To understand that, let's first discuss what is inheritance. So inheritance in programming languages generally refers to passing down the properties from parent to child such that child can reuse those methods and properties coming from the parent, or child can modify those methods and properties to fulfill its needs, or maybe child can extend those methods and properties so that child can build its own set of features based on the properties and methods coming from the parent. So the concept of reusability is called the inheritance in programming languages. So as you can see, dog inherits from the mammal and mammal inherits from the animal. So dog has access to the methods and properties coming from the mammal and also has access to the properties and methods coming from the animal. So that is called inheritance. And the JavaScript language feature which supports this inheritance is called prototypal inheritance. So prototypal inheritance is actually a JavaScript's language feature which supports inheritance in JavaScript. Cool. Now what is prototype? So in JavaScript, every object has a special hidden property which is named prototype with P capital in double square bracket. Right? That is a special property in each object and it's a hidden property, and this is literally the name of the property as per the ECMAScript standards, right? And what are the possible values for this prototype property? The possible values are either null or it points to the another object. So this prototype property in double square bracket, it can be either null or it points to the another object, and this property itself is called the object prototype. So let's see here in the example. So here we have the object and it has a property prototype and it points to the another object, right? Because it is pointing to the another object, then this becomes the parent of this object. So this is the parent object and this is the child object. So this property is called the prototype of object, which is the child object, right? So this is called the object prototype, right? Then what is prototypical inheritance? So prototypal inheritance is actually when JavaScript tries to read the property from the object, right? Then if the property found on the object itself, it's well and good, we are good then and there itself. But if the property does not exist on the object, then JavaScript follows this prototypal chain. Then JavaScript moves to the parent and it tries to find the property then and there itself. If property found, JavaScript returns that property from the parent itself. But if the property does not exist on the parent also, then it follows its prototype hierarchy, that parent must have some pointer to the another object also, and it keeps on reading the chain until it hits the null, because we said that the prototype property, it is either null or it is a reference to another object. So it keeps on following the references until it reaches the null. That way we achieve the inheritance in JavaScript. So a quick summary is, what is prototype? So in JavaScript, every object has a special property named prototype in double square bracket. This property is called the prototype of the object. And what are the two possible values for this property? It is either null or it points to the another object altogether. And when it points to the another object, then it sets the inheritance for that child object. Because whenever JavaScript tries to read the property in a child object, if the property does not exist, it follows the prototypal chain to read the property until it keeps on reading until it hits the null here, right? I hope this makes sense. Now let's discuss how do we set the prototype property of the object. So there are multiple ways to set the prototype of the object, and we will discuss few methods in the upcoming videos, but as part of today's videos we will discuss the underscore underscore proto property, because it is one of the oldest method to set the prototype of the object. And to make our basics clear, or to understand the prototypal inheritance more clearly, it is very much required that we understand the basics, how we set the prototypal inheritance. Cool. So this underscore underscore proto property is used to set the prototypal inheritance for any object. So this actually acts as a getter setter for the prototype of the object. We can use this property to set the prototype for any object, and the syntax is child dot underscore underscore proto property is equal to parent. So this is a special property. Whenever we assign something to this property, it actually internally set the prototype of the object to the parent. Basically it sets a relationship between child and parent. It sets the prototype property of the object and marks the pointer to the parent, so that JavaScript can follow the hierarchy or the link while reading the properties from child to parent. So while reading the property, if the property exists in child, well and good, else JavaScript will move to the chain and it will try to read the property from the parent. So this is one of the possible way, and today we will discuss this property underscore underscore proto in detail. Cool. So now let's discuss the default prototype. So all objects in JavaScript inherits from the default object, which is object.prototype, right? So if I create a object using any of the method, for example, here I initialize the object using the object literal syntax. Here I initialize the object using new keyword, and I use create the object using object.create. So no matter which method I use, by default every object will have its prototype set to the default object.prototype, and it has few default methods already available for uses. That is why you must have seen that the toString or has on property, these are some of the methods which are readily available to use in some of the object, and because JavaScript read those properties from the prototypal chain of that object, and the prototype of this particular object is null. So here the link stops, or the prototypal chain stops here, right? So this makes sense. So every object in JavaScript inherits from the default object, which the name of the object is object.prototype, and it has few set of methods readily available for uses. Now let's discuss this in practice. Cool. So I have some environment setup, code environment setup. So this is the HTML file, and here we are referring the JavaScript file, and it is the console log hello world which we are seeing here. Now let's create two objects. I will delete this. So I have two objects. One object is user, which has a name property get name, and there is a method greet which says welcome to JavaScript, and there is another object admin, and it has a single property is admin. Now let's try to log one of the object here, and here we are using the object literal syntax to initialize the object, right? And I logged this object. So let's analyze what we have available in the object. So in the object we have a is admin property, because is admin we have defined. Now if you see clearly, there is a prototype property also available in the object. As we discussed in the last topic, in JavaScript every object by default inherits from the object.prototype property. So this is the object.prototype, which has some of the default methods available in it ready to use, which we can make use of. For example, I can do this admin.toString. Now from where this method is coming? This method is coming from its prototypal chain. This method is coming from its prototypal hierarchy. That is why we are able to use this method. And if I call some other method, for example string 123, it will throw an error, right? It will say is not a function. ToString123 is not a function because this method does not exist neither on the admin nor on its hierarchy. This method does not exist anywhere. That is why it is throwing an error, and this is coming from the hierarchy. Make sense? So this discussion we did just to validate that our JavaScript objects are getting inherited from the default object.prototype. Now let's do the inheritance setup. Now let's inherit admin from the user, right? So to achieve that, what I can do is, as we discussed, we can make use of the __ proto property user, right? So we set the inheritance there. We set the __ proto property 2 underscores of the admin to point to the user objects. Now we change the linkage. Let's see what happens internally. So we have the isAdmin, right? IsAdmin true because it's a self property, and this has a prototype. It was earlier there as well, and now we change the reference, or we change the prototype of the admin object. Now see what is there. Cool, it got changed. Now it is pointing to the user. Now user has a property name which is there, and it has a method greet which we can see in the prototype hierarchy, right? And user, because it's a object literal, it is further pointing to the its parent, which is the default object.create method. So we change the prototype of admin from the default to the user. So what we did here is change the prototype from default to user. Make sense? Now if we try to read the property, console.log admin.name, right, and say admin.greet, is admin.name and console, sorry, spelling mistake. Cool. So it says admin.name Manish Kumar, and name property, if we see, does not exist in admin itself. So it is following the prototypal chain or the hierarchy, and it is reading the property from here, name, right? And it is called, and we are calling the function also, which is reading the method from the prototypal chain only. So it is calling the method which is available on the user. So this is how we achieve the prototypal inheritance in JavaScript. Now this is a 2-level hierarchy. At the very first level we have a user, second level we have an admin, and it can be n level long. We can create a one more level like guest also, and I can set the prototype in the literal syntax itself, and I will set it to point it to admin. So guest inherits from admin, admin inherits from user, and now I can try to log this as well, guest dot name. So it prints Manish Kumar here. So it is reading the property. Now let's try to log guest as well, console.log GUEST guest. So it has a is guest. Let's change the property name to is guest. So it has a is guest property as a self property. Then it goes to the parent, which is a prototypal chain. It has a is admin property. It further goes to its parent. It has these two properties, and this further points to its further parent, and it has a property, few set of properties available for usage, right? So that is how we achieve the prototypal inheritance in JavaScript. And JavaScript is reading the properties from the object first, and if it is not available in the object itself, then it is following its prototypal hierarchy. It goes to its parent. If property is not found there also, it goes to further parent till we reach the end of the prototypal chain. I hope this makes sense. Let's move forward. Okay, so it says this has a limitation. The references cannot go in circle. Basically, if C inherits from B, B inherits from A cannot inherit from C. If we try to set up that linkage, JavaScript will throw an error, right? So that is the very first point to take care of. The value of underscore underscore proto property, it can be either object or null, as we discussed earlier. It cannot be anything apart from these two values. And object may not inherit from two objects. So like in other object oriented programming languages, our child can inherit from two base classes, but in JavaScript we cannot do that because it's a single way pointers that our child object or our object can points to the one object only, or it can has a single parent, or it can has a single prototypal hierarchy which it will keep on following to find the property. So we can have only one object as a parent of the child object. So that is something which we have to take care of. Now sometimes student confuses that underscore underscore proto is actually the prototype of the object, but that is not true. Underscore underscore proto is the getter setter for the prototype property of the object, right? That is something which you have to take care of when working with JavaScript, because here we can see underscore underscore proto we used here to point to the user, and it is actually setting the prototype property. This prototype in the double square bracket, it is actually setting the value of this prototype property to point to the another object which becomes the parent of the child object. Cool. Now let's discuss the writing part. So when we try to write on any child object, right, then the writing happens on the object itself. Writing does not happen on the parent, right? That is something which to be taken care of. Now let's test this in practice. So I will delete this as of now, and this also we will remove to keep our code simpler, right? Now let me do one thing. Admin dot age is equal to 40. Let's do that. Now what do you think where this age property will go? Because admin is prototypically inherited from user, or admin inherits from the user, right? But that does not mean the age property will go here. That does not mean age will get written on the user object. No. Whenever we try to read something, it follows the prototypal chain. But whenever we are writing something or deleting something, then those operation happens on the object itself. So if I'm writing admin.age 40, then that will actually write on the object itself. Let's test it. So here you see age property gets written on the object itself, or maybe let's override the name property. Name Manish Kumar, hello world. So earlier the value was Manish Kumar, and now we change the value to hello world. Now what do you think? What will happen to the name property? Will the original name will get overridden, or the name will get written here as a new property? So as we discussed earlier, whenever we are writing to any object, the property will gets created on the object itself. So in this case, name will gets created on the admin itself. It will not change or modify the value of the parent, right? So let's see it. Yes, so age property gets written and name gets written on the admin itself, and parent also has a name property which is Manish Kumar. So now parent has its own copy of name and child has its own copy of name. Now let's do one thing. Admin dot name I print this, and I will print one more time admin name, and between this I will delete the property admin.name. So what we are doing is we are writing a name property on admin which is setting to hello world, then we are printing the name, and then we are deleting the property name from admin, and then again we are printing the name. Let's see the outcome. So the outcome at line number 18 is hello world, because we wrote the property admin here. We wrote the property name on the admin, right? So then when we are reading the name property, JavaScript find the name property on the object itself. JavaScript find the name property on the admin object itself. So we get the value as hello world. And now we delete the property. So the name property gets deleted from this admin object itself. And next time when we are printing the name, because name now does not exist on the object itself, which is admin, it follows its prototypal hierarchy. It follows the parent, and there we get the property name and the value is Manish Kumar, right? So that way always writing and delete operations happens on the object itself, the object on which we are writing that property, right? Make sense? Now let's see the exception. So writing rule has one exception to the discussed topic which we just see on the last slide, which is the accessor properties, the getter and the setter properties. So whenever the property is of type getter and setter and it exists on the parent, and if we are trying to write to that property, in that case JavaScript will not write to its child object only. JavaScript will call the parent getter and setter method. Let's understand this with the help of an example. Okay, so let me, here we were doing the okay, let me set the full name property. Full name is hello world and I will print the full name, and console.log, right, and I will print the admin object. Okay, see, and let's remove the age also to keep the minimal properties. Now you see we have the full name property here on the admin. So whenever we try to write the property named full name on the admin, right, so it created a property on the admin itself. So the value of full name is hello world. Now let's see what happens. I say I create a getter setter for full name, get full name and return this dot name, my name is this one, and I create another setter property, set full name, right, and it will receive a value, right, and for the time being I'm just logging the value, console.log value is value. See what happens. So now whenever we are trying to write to the full name, because full name is a setter property which exists in the parent, full name is a accessor property which exists in the parent, it's a function. So whenever we are trying to write to this property, this function gets executed internally because JavaScript find that it is a accessor property, and whenever we are trying to write, it calls that function here. So as a result, you see this full name does not exist on the admin now. Now admin has only one property, which was the original property is admin. And if we expand this, you see we have only one property is admin, which is a bit bolder, and the accessor properties, if you see, there is a slightly styling changes here. It is a dim property or a not bold property, which represent that it is a accessor property or a getter property, and if I click on that, it will print my name is Manish Kumar, and the accessor properties are available on the child objects also, but it is not the direct property of the admin, it is coming from the parent only. The direct properties or the self properties of the object are bolder in blue color, and the accessor properties are lighter in blue color. Make sense? So the topic which we discussed, that writing and delete operations are happen on the object itself, there is one exception to that rule, which is the accessor properties or the getter and setter properties. We all know setter properties are actually the functions, and whenever we try to do an assignment to setter of properties, then that function gets called internally. So the same is happening here. Whenever we are trying to write to the full name property, JavaScript knows that full name is a setter property. It calls that function. It calls that function and with the value which is here. So that is why the full name does not gets written to the admin, rather it gets called as a function. And now whatever we can do in the function, so basically I can create this dot name is equal to value. This dot name is equal to value. Now what will happen is, what we are saying is, so write a property name on the object. So this points to the object, right? Whichever is calling it. This points to the object, whichever is calling it. So it says initialize a property name with the past value. So what will happen is, when we are calling admin.fullname hello world, it actually will initialize the name hello world on admin. Make sense? So full name is actually a setter property which is calling a method, and inside that method we are calling the property named name, and it initializes the property name. It initializes the property on the admin object. I hope this makes sense. Now the very much important topic is to which object this points to, because this function exists in the user object. If you think this will always point to the user, no, this always points to the object before the dot. Basically the object which is calling the method, this always point to that object. And here we are calling the object full name, we are calling the function full name or the property full name on the object admin. So that is why it is actually admin dot name is equal to value, and that is why we can see that the name property gets created on the admin. So this is how the this operator works in JavaScript. There is a single line answer to this question, to which object this points to. So this always points to the object which is before the dot. So before the dot we have the admin object. That means whenever this function gets called, or any function in the prototypal hierarchy, it doesn't matter where that function exists. If that function exists in the 10 level above hierarchy also, or anywhere in between the hierarchy also, this will always point to the object which has called that method. And here we have called full name on the admin, so this name property will gets created on the admin itself. I hope this makes sense. We already discussed the value of this. This is not affected by the prototypal inheritance or the prototypes at all. This always points to the object which is before the dot, and we already discussed the example with the help of this getter and setter, where we initializes the name property on the admin using the setter function. Make sense? And we also discussed that setter properties which we see here when we are logging the object are not the direct properties of the object. The direct properties are is admin, or in this case name only, because these are bolder and blue in color, and the setter properties or the getter properties or the accessor properties to call it are lighter in color. And when we click on that, it actually calls the function. So it calls the full name function, right? And it says my name is hello world, and this time it is this pointing to the admin object because we are looking at the admin object, or we clicked on the full name property of the admin object. So it says my name is hello world. Makes sense? Okay, now for in loop. So for in is a special loop in JavaScript which also loops over the enumerable properties. Enumerable means the properties in the prototypal chain, or the properties coming from the parents as well. So let's understand it with an example. For let prop in admin console.log prop and prop. So it says we looped over the admin object, right? And admin has these two properties only, is admin and the name, using this method. Or maybe for now let me remove this full name property also, and the getter setter also, to keep the code minimal. So we have prop isadmin, which is on the object itself, and we have the prop name and greet, which is on the parent, right? So we print those as a console log here, that for-in is actually able to get the properties from the parent hierarchy or from the prototypal chain as well. And let me log the admin as well. So we printed the admin, which is here. We printed the greet and name, which is here, but it does not printed the further properties which is in the prototypal of the parent, because I said for-in only iterates over the enumerable properties or the properties whose meta has set the enumerable as true, basically, which can be iterated over, and these all default properties has enumerable as set to false. That is why these all properties does not comes in the outcome of the for-in loop, or these properties are not available when we are looping through the for-in or the object's properties. And how we can check if something is object's own property or something is coming as a inherited property? For that we can use admin dot has on property prop. So we will check if prop is actually the on property of object or not, and we, in that case, we will log something like this, and on property and here I will say inherited property. So it says on property is admin and inherited properties are name and greet, because those does not exist in the admin itself, those are coming from the parent. And has on property is a method which helps verifying that if a property is part of the object itself or not. It returns true or false. So that is how we are logging this properties here only. Now you must be wondering from where this has on property is coming, how we are able to call this has on property method. It doesn't exist on parent. You might know the answer because it exists on the prototypal chain of the user. So let's understand it here only. So is admin and its prototypal parent is greet, has properties greet and name, but its further parent has a few ready to use method, which we discussed that every object in JavaScript by default inherits from the object.prototype, which has some ready to use methods already available for us. And here we have the method has on property. So when we are calling admin.has on property, it is actually trying to find first here not found, then it goes to its parent, it tries to find here not found, then it goes to further parent and it founds the method here. So it is calling the method from the 2 level above. Make sense? Yeah, this topic we already discussed, that all objects in JavaScript inherits from the object.prototype, and here we have some methods which we can follow the prototypal chain to find those methods and execute those methods on the objects and properties which we have available for uses. So quick recap, we discussed what a prototypal inheritance is, right? What is a prototypal inheritance and what is prototype? So prototype is a special property which exists in every object, and it has only 2 possible values. Either it is null or it is a pointer to the another object. And that way we set the prototypal hierarchy or a prototypal chain which JavaScript follows to find something when we try to read from the object. So we discussed the method __ proto, which is the one of the oldest way to set the prototypal hierarchy in JavaScript. And we discussed that every object in JavaScript by default has a link to the object.prototype, which has few methods available to use. We discussed with the help of some examples, we discussed some limitations, then we discussed that __ proto is not is equal to the prototype of the object. Rather, underscore underscore proto is a getter setter for the object's prototype. We discussed that writing always happens on the object itself, where we are calling that property or the method. But the exception to that particular rule is the accessor properties or the getter and the setter properties. We discussed the value of this is always the object before the dot. So keep remembering this point. The for in loop always iterates over the enumerable properties, the properties which comes from the parent as well. So object.prototype is the default prototype of every object. Cool, makes sense. And one more thing here. If apart from this for in loop, the other method like object.keys always gives the self properties only. So it gives only isAdmin. So for in loop is the only way in JavaScript which iterates over the properties coming from the parent as well, and only those properties will be looped over which are of type enumerable or whose enumerable meta is set to true. So for in loop actually iterates over all the properties coming from the parent. Now let's discuss some interview questions here. So guess the outcome. We have an animal object which has a jumps property set to null. Then we have a rabbit object which has a jumps set to true, and it inherits from the parent. It inherits from the parent animal. So when we do rabbits.jump, yes, we find the property jumps in the rabbit itself. So it should be true. Then we delete the property. So in this case, it will follow the prototypal chain, and we will find the property in the animal. So it will be null at this layer, at this statement, and then we delete the property jumps from the animal also. So here it should be undefined because jumps property does not exist on rabbit also, does not exist on animal also, and in that way it should be undefined. Let's verify our understanding here. Cool. So the very first time it is true, makes sense. Second time it is null because it is going to its parent, and for the third time it is undefined because it doesn't exist at this level, it doesn't exist at this level, or it doesn't exist, it's further the default prototype level as well, and on top of that it's null only. So there is no more linkages on top of that level, so it is undefined. Cool. I hope this makes sense. Now let's move to the second question. Okay, so we have 4 objects given: head, table, bed and pocket with some properties. It says that set up a hierarchy in a way that pocket goes to bed, bed goes to table, and table goes to head. And after setting up this hierarchy, if we try to read pockets.pen, it should actually follow this hierarchy and should print 3. And if I try to read bed.glasses, so glasses does not exist here, it should follow the prototypal hierarchy and it should log 1. Cool, we got the question. Now let's try to set up that. So I will set up the underscore proto property to bed here, and this and this. So it will point to head and it will point to bed, sorry, table. So now pocket inherits from bed, bed inherits from table, and table inherits from head. We set up the prototypal hierarchy, and that we can check by using or by logging the leaf node or the leaf object, which is the pockets. So pockets has a self property as money, and then it has a prototypal link to the another object which has 2 properties, sheet and pillow, which has a prototypal link to another object which has a 1 property pen, and this has a prototypal link to another object which has a glasses, and it has a prototypal link to the default object which is a few set of methods. And now if I try to log pockets.pen, yes, it is 3, and bed.glasses, yes, it is 1. Yep, we did it. it is working fine here. Now the second part is it faster to get glasses as pocket.glasses or head.glasses? So basically it says which is a faster way to access the glasses property, directly reading from the object or following the prototypal hierarchy and reaching to that particular property. So the answer to this particular question is it's almost similar, because whenever we do the first read operation from the pocket, it will follow the path, and wherever it finds the property, it will directly establish a link internally that glasses property is available under the head itself, and the subsequent operation will be exactly equal to as if I'm reading the property from the object itself. So it's only a matter of the first read operation, which can be slightly slower because JavaScript is finding where the property does exist, but all the subsequent operations are as fast as if the property exists in the object itself. So we can say it doesn't matter where the property exists, the performance will be quite similar whenever we are following the prototypal chain or we are reading the property from the object itself. Cool. Let's move to the next question. So we have an object given animal which has a method eat, and it is trying to set the property full to true, and we have a rabbit which inherits from the animal. It says when we call the object on the rabbit, when we call the method eat on the rabbit, which object receives the full property? So this full, where does it get written? To the animal or to the rabbit? So we earlier discussed that whenever we call the method and that has a pointer or that is referring to the this, in that case this always refer to the object which is before the dot, and here before the dot we have rabbit, so it will actually be rabbit dot full, right? So that means we are writing to the rabbit, not to the animal. Let's see this as a help us with an example. So I will comment this stuff here, and let's come here, and let's log this console.log rabbit. So you see here, so rabbit has a property full as true, and its parent, which is a prototypal inheritance, has only one property eat, because as we discussed, whenever we are calling the method, this always point to the object which is before the dot, and if we are writing full, which actually means rabbit dot full is equal to true. So this points to the rabbit here. So this points to the rabbit here. So we are writing the full on the rabbit itself, not on the animal. So practice this particular thing. And last question we have is, we have an object hamster which has a property stomach, which is an array, and we have a method eat which is getting a food as a parameter, and we are pushing that food to the stomach object, stomach array basically, and we have two objects which inherit from the hamster, and we are calling the method eat on one object, speedy, and when we alert that, it gives apple, and when we alert the other object lazy.stomach, it also gives apple as an outcome. Why so? So this is a very important question and the important concept to understand. Let's understand what is happening here. So it says apple for the speedy.stomach and apple for the lazy.stomach as well. Maybe let me do the console.log here instead of alert. Console.log speedy.stomach. Yes, apple we have here, and apple we have the second console log statement as well. But why lazy.stomach is apple? We haven't called the eat method on the lazy, we called the eat on the speedy itself. Let's understand what is happening here. So we said that this always points to the object on which this method is called, or the object before the dot. So we have a speedy here. So what internally is happening is this is speedy dot stomach dot push. So internally what JavaScript is trying to do is speedy dot stomach, which means it tries to find the property stomach on speedy. So JavaScript goes here speedy dot stomach, but stomach does not exist here, right? So it follows the prototypal hierarchy. So it goes here in the parent object, and now this speedy dot stomach is actually pointing to the stomach property of the parent, and we are pushing on the parent itself. So after this execution of this statement, stomach is apple on the hamster itself, right, on the hamster itself, but not on the speedy, because stomach property, when we are trying to read here as speedy dot stomach or this dot stomach, JavaScript tries to find, but it doesn't exist there, and that we can check with the help of console log as well. So I will do console.log speedy and speedy, right? So speedy itself does not have any property, but it has a prototypal hierarchy and it has a stomach, and that stomach gets returned to the apple, or the apple gets pushed to the property on the parent itself. So you have to take care of this thing, that whenever we are trying to read the property from the child, if property does not exist, JavaScript goes to the parent. And if we want to avoid, or if we want to fix this particular thing, then we have to do the assignment operation, so that we initialize the property on the child itself. And if I do this, now let's see, now stomach gets created on the child itself. Earlier what we were doing is this dot stomach dot push. Basically we were doing read the property this and push on that property. Basically we were not reinitializing the property, we were reading and just pushing on top of that. And to fix that, we can just redeclare the property, or we can do the reassignment, so that even if the property does not exist, it gets created on the child level. So that is how now our stomach is apple here at the speedy level, but at the parent level stomach is empty now. I hope you got the solution to this particular problem, that whenever we are trying to read the property from the child and we are not doing the reassignment, we are just appending or pushing, and if the property does not exist on the child, then in that case JavaScript will follow its prototypal hierarchy to find that property from the parent. There is one more solution to this particular problem. We can keep our method same, speedy, right? Rather I will initialize the speedy here also, so that whenever we are doing this dot stomach, which is speedy dot stomach, JavaScript find the property in the child itself, and JavaScript will not follow the prototypal hierarchy. JavaScript will take this as a value and push on to that stomach only. So now if we see, stomach has a value apple, right, and its further prototypal hierarchy, and its prototypal hierarchy points to the empty object. So I hope this makes sense. You get the solution to this problem as well, and these are the few interview questions which you can practice and clear your understanding on the JavaScript prototypal inheritance. And this was it about the basics of the prototypal inheritance. So in today's session we discussed the one of the oldest way, which is the __ proto, to set the prototypal inheritance. And though this is the non-standard way to set the prototypal inheritance, but this exists in all the major environment, like in all the browsers and in the Node.js environment as well, which we can leverage to set the prototypal inheritance in JavaScript. So we will come up with the next videos on this particular topic only, where we discuss the another ways how we can set up the prototypal inheritance, but this is the base. So clear your understanding on this, and the other methods are built on top of this only. If you like our videos, please consider like, share and subscribe to our channel so that we keep coming with such videos and we keep learning and keep growing in our careers. Thanks for watching. Stay tuned. Bye bye. Take care.